subtract this out. You take the whole area from 0 to 4, subtract out the area from 0 to 1, you'll be left with that region.
It's also the height will be 6, not 8.
Yeah, so right here, that height would be 2, that would be 8. You could do, if you wanted to, you could do area of trapezoid.
Huh. So what is the total height? That means like what will be the total height? 2 and oh, you have to do two heights, right?
Yeah. I was thinking this, like just to check this,
Uh-huh.
Art, I was thinking we could just say, oh, think about this. This is like the area of the triangle from 0 to 4.
Yeah.
Alright. Subtract out the area of the triangle what?
0 to 1.
0 to 1. In that image. And we're getting 16 minus the 1, which is what?
15. Okay.
But if you wanted to check it another way, you could go, well, what's the area? That's a trapezoid, isn't it?
Uh-huh.
When a trapezoid is a four-sided quadrilateral where there's two sides parallel, and you gotta do half the base times some of the.
So yeah.
So if you think about the heights are on the side, aren't they?
Yeah.
So you'd be like half the. So there's base 1, that would be base 2, and the height there would be what, 3?
3. Yeah.
If anybody wanted to, and when the area of a trapezoid is 1/2, right? The height of the trapezoid times the sum of the bases. The only thing is when you look at that, you gotta think of the height being like on the side, because the big faces have to be parallel to each other. Anyone good with all that? Hey, cool. So I'm gonna erase this. Everyone, thanks for bearing with me on that. I wanted to make sure you got a sense of these two things, because we were hitting them all day today. Fundamental Theorem of Calculus, Part 1. Fundamental Theorem of Calculus, Part 2. Just call them FTC. And Friday, I'm going to go to your question. All right, so I'll make it a different constant. How about 3 this time? Whoops. This was an x, this was a 3. 2t dt, and let's try this again. According to Part 1, Fundamental Theorem of Calculus, what would the derivative of x have to equal?
2.
No matter what, according to the Fundamental Theorem of Calculus, Part 1, it will just equal what?
2.
This right here. This function. But you got to substitute what variable for t?
X.
Is that good? Is that good enough? All right, let's make something crazy. Let's make something like just bizarre. G of x equals, this time we'll go to 5. You all know this constant's not matter in this expression here. Here's the variable x. Cube root t to the 5th minus 7 dt. And you and I have to find g prime of x. Well, according to the Fundamental Theorem of Calculus, right?
Mm-hmm.
Let me just make sure that function's continuous. Yeah, it's cube root. We're okay. What would this come out to be? Cube root minus 7 to the 5th power. The only thing is, what variable do I have to use?
X.
Because it's in terms of x. And if you ever get confused, why is this happening? I want you to go back to our example. When you saw it just come back to be that 2t, remember? And then we got the 2x at the end. Right? We went through it. Now, your question. Now, what if this switches around? So that means the whole thing gets reflected on the x-axis. Where there's a property of integrals. And it says this. Can you switch things like this? Oh yeah. But because of symmetry, wah, wah. As long as the function's continuous, right? This property holds. So I can do that, and we can switch it, but what symbol do you have to put down?
Negative.
Negative.
Oh, so you're doing a lower bound and upper
There you go.
switch. Okay.
That's what's happening. It's like the whole thing just got flipped over. It's that simple. So hey, let's do one. I'm going to make up an expression. I'm going to put the variable down here this time, okay? I'm going to put the number up here. You can make up any function here for us, and we'll write the answer. And then, then we can put a negative in front of it. So we'll try this one. Alright, everyone here star this, because look, he came up with this one, it was good. We're putting the variable here. Alright, that's a 1. Now make up some function, anything.
19.
Alright, 19. And that's a 9, let me make sure it doesn't look like a G or anything. 9t dt. Alright, what would g prime of x have to equal? Well,
9x.
the first thing I have to do is really, it's gonna be this but negative. It's gonna be a 9x but negative.
Why is it
But
negative?
because it's property, the first thing I should do is apply it and just say, by this property, it's equal to negative, and then I get to do what? Switch them around. So now we know that the answer with g prime of x, it'll just be negative, constant in front, and then just what? 9x. The biggest error, students sometimes they go, why is x, why, this is t, how's it become an x? It's because doesn't that x get substituted?
Mm-hmm.
That's why. I throw students off sometimes, I don't understand why it's not t in the end. It's because x actually got substituted. Why didn't the 1 hang around? Because you took the derivative of a constant, it turns into 0. Isn't that cool? Alright. So the answer to this one? Negative 9 of x.
Would you switch the x and the 1? X was on the top, or on the bottom.
Yep, we switched them over, but we had to put a what?
Why
negative
did you
there.
make it a negative again?
Oh, because of this property.
How do you know when you're supposed to use that?
When the variable is on the bottom. Good deal.
I'm having some hard trouble understanding the difference between the two. The part 1 and part 2.
Okay,
When do you use?
great question. I'm gonna give you a couple examples. Most of the time, you're just gonna use this. You're not gonna see many of those. But, what we're trying to emphasize with part 1 of the fundamental theorem of calculus, we're trying to emphasize how the derivative of this will just be what? Yeah, that derivative of this expression in terms of x. You know what I mean? Like, g of x took the integral, and then you come back to this. So, I'm gonna pick a problem out of the book, so you get a sense of this one. And when this is like page 394. And don't worry, I'm gonna come back to 5.2. I'll come back to 5.2, but this is like page 394, number 3. That's one of the practice problems I saw, okay? So I'm gonna make something up, I'm gonna make some image. I'll play around with this. Alright. And when I gotta make something that I know you know how to find area under, so I'm gonna use straight lines, okay? Can we find area of triangles and things of that sort? Right, without calculus? So here we go. One, 2, 3, 4, 5, 6. How did I make this? I'm gonna go up to 5. 1, 2, 3, 4, 5. 1, 2, 3. All right, I'm gonna have this graph start here at 3. At 1, it's gonna get to 5. At 2, it's gonna get back to 3. At 4, it got to 0. This graph's gonna go like this. Yep. 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 1, 2, 3, 4, 5, 6. I'm gonna call this T. All right. I'm gonna call this the graph of F. I mean, that's a function, right? And I'm gonna write this. Let g of x be defined as this. So I'm making this up. This is like that problem. And Rod, this is so you can better understand this, like when do I use this? When do I need to do this? It would be a problem if they just told you to find a derivative, you know, just put that there, right? But here's this problem. Most of these start at 0. I don't like that, so on purpose I'm gonna start this thing at 1. Okay? So that's the number 1. I'm gonna put the variable t right here. And I'm gonna put f of t dt. Okay? Now everyone, don't integrals deal with area?
Mhm.
Okay. So we're gonna start finding areas. That's why I use straight lines. This better help you better understand fundamental theorem of calculus part 1. And this is like that problem out of the book. So what do I want you to find? Everyone, I want you to find the v-values. Now notice I started at what number? 1. I did that on purpose. The textbook always starts at 0, and sometimes students get to a test and they assume you just start at 0. You know, your eyes just start right at the origin. Well, this thing's starting at 1, so I want us to find these. And let's just call this letter A. Everyone, letter A, I want you to find g of 1. Then I want you to find g of 2. Then I want you to find g of 4. And finally, I want you to find g of 6. Okay? Now, what is g? G is defined as what? G of x is defined as the function that's the integral from lowercase, lower limit 1 to variable t of f of t. Now, if this looks all confusing, don't let it be confusing. Everyone go back to Algebra 1 class. What if I said, oh, g of x equaled 5x plus 2, and I asked you to find g of 2, you all know what you do. Where do you substitute the 2?
X.
For x. Did everyone hear that? Go back down and go, what'd you do? You substitute 2 for what variable? For an x, back in Algebra 2, correct? Okay, so I want you to do the same thing here. I need you to find g of 1. Then you say, I'm going to substitute what number for x?
1.
A 1. So that means going to this whole right side, and I want you to find, oh, let me make that an x, I apologize. Oh, it's been all messed up, I apologize. We're going to substitute 1 for the x value in that right side of the image. All right. So I want to find g of 1.
Can you have an integral with the same number of both sides?
Yep. So this is what I'm getting. Now, what do you think this answer is going to be? Find the area underneath this function from
0.
1 to 1.
0.
So in one of the properties of integrals, what's the integral going to be when you go from the same number to the same number here? Every time, right? Because you can find in the area underneath from here to here, you're not going anywhere, so what will it be?
0.
0. So what's g of 1 equal to? You and I don't see g, do we? What picture are we seeing? What image?
F.
F. But I'll tell you what, when we're done, you and I can build g. Isn't that cool? We can actually build the g function. We know one number so far. What's g of 1?
0.
0. So hey, I mean, just as we go through this course, when I make up some function later on and I go from 5 to 5 of x cubed dx, could you tell me what the answer is going to be?
0.
0, right? We're saying if these are the same, you're always going to get what?
0.
0. Everyone so far so good? Now notice, we said, yeah, if you're plugging in a 1, you just plugged in a what right here? 1. Well, let's go to this. Now take it slow. What does g of 2 mean? It means go into that equation on the right side and substitute what for that x?
2.
2. F of t dt. And you and I say, well, integral's fine. We know by Riemann sums area underneath the function, between the function and the x-axis. True? Right, built all those infinite amount of rectangles. All right, let's get the area from 1 to 2. Now, I put straight lines on purpose so you and I can find the area. So, what are we trying to find?
1 to 2.
Oh, we got to find this area. Now, we got to use geometry, okay? We're going to have to use geometry. We got to find that area. But I know we all know area of rectangle. Length times what? Width. And we all know how to get area of a triangle. half base height. Somebody might go, hey, that's a trapezoid, right? But you might not mess with it. Can't you just get the area of the rectangle, the area of the triangle, and add them together? Yeah, most students do that. Good. So let's find this area right here, because that's what it's going to be. We're trying to say find the area from 1 to 2. Is it going to be positive? Yes, because it's above the what? X-axis. You and I are going to be very careful when this function dips below the what? X-axis. You go, why? Because then we know y values go negative. And if that's the original definition, that means y, so we're just going to be careful. But right now, everything's above the x-axis, true?
Mhm.
So let's write in here the area of this. What's the area of this whole region right here? That rectangle.
1 times 3.
That's an area of 3, length times width, 3.
Uh-huh.
Cool. Now you can do a half base height there.
1.5.
So 2.
So half of 1 times, what's that height
2.
there?
No, 2.
Alright, I'm just going to draw an arrow like this, and you got to do half the base length, 1, times the height, 2.
2.
What's a half of 1 times 2? 1. Everyone agree?
Uh-huh.
Let me just make sure. Is the area of that little triangle 1? Sometimes it gets confusing. You're like, wait, and you're like, oh yeah, what's that length of that base? 1, what was the length of that height there? 2, alright, what's 1/2 of 1 times 2? Everyone so far so good?
Uh-huh.
Cool.
We found the 3, but just finding the height.
Oh, do you agree? I'm saying the area from here up to there is 3. And all I did was area of the rectangle. Thanks. Area of the rectangle, length times width. And you go, all right, the width, this length is 3, this width is 1. True? All right. Now, you got to sum those areas. What is the integral from 1 to 2, the definite integral? What's that area?
4.
Let me make sure. Is everyone okay with this? Yeah? Cool. So g of 1 was 0. What's g of